Okay, so now I'm going to start. So in this session, basically, I will give the idea about the natural language processing. And if you are interested to work on NLP, then in the academic line, that in this case, what are the procedure we will follow to develop any model in NLP using the natural language processing. So you already know the advantage of using the NLP, because based on the NLP, natural language processing, is the technology used to understand, used to at the computer to understand the human natural language, something like that. So NLP is basically the short form, we are means the long form we are saying like the natural language processing. Usually we call as NLP, and basically here we are dealing with the text data. Here basically we are dealing with the text data. So Alexa is one good example of NLP. So we are converting the audio data to the text data, and after that, based on the text data, we are going to find the meaning of the text data, and finally we are converting this text data to audio data basically in the NLP. So these are the mainly part of the NLP. When you are working for the NLP, these are the broad category of the NLP. So first one, your language translation. So this is also one part of the NLP. Basically we are going to translate one language to another language using something like that. Second one is your sentiment analysis. So most of the company, they are using this term called sentiment analysis. So based on the comment of the user, they are going to find whether this is a positive sentiment or negative sentiment. So they have developed some model, and based on the content of the text, they are going to decide whether this is a positive sentiment, negative sentiment, or neutral, something like that. Same like that when you are working for the email system, that in this case, based on the content of the email, you will decide whether this email will go to the inbox or it will go to the spam folder. So based on the content of the data, we are going to decide whether it will go for the inbox or it will go to the spam folder. Next one is called the software defect severity level. Means based on the types of the defect, based on the comments of the defect, we are going to decide what is the level of this defect. So as for example, if this defect is more critical, then we will assign this defect to the good tester, something like that. So we have the group of testing persons. So some have the good experience, some have not that much experience, means 1 year experience, 2 year experience, and 10 year experience. Then in this case, based on the level of the defect, we will assign this defect to the higher testing person or something like that. So here basically we are using the software defect severity level. So based on the content or based on the text of the defect, we will decide what is the level of this defect. And in this session, basically I will focus on NLP, but we will take one example of one data set that is called the software defect severity level. So basically the software defect severity level, our aim is to assign appropriate severity level. So basically we have the different types of level 1, level 2, level 3, level 4. So based on the types of the level, means based on the content of this defect, we will decide whether this is a critical event, whether this is a critical defect, or whether this is a major defect, whether this is a minor defect, something like that. But when we are working for the NLP, not for the defect severity level, when we are working for any types of NLP, then in this case, mainly we are getting the 3 technical challenges. So first one, your word embedding, second one, your high dimensional data, and third one is your imbalanced data. So as for example, same like that, if you are working for the job recommendation system and you are going to consider the resume of every student, and based on the resume of the student, you are going to predict whether the student will get job or not. So here basically the first objective, because the machine learning technique only understands the numerical data, it will not understand the text data. So here our first objective is to convert this text data to numeric data. This is our first objective. And most of the time we are using the count factorizer or we are using the bag of flow. We simply, for example, now assume that we are going to convert this whole text into the number. Then in this case, basically what we are going to use in the case of count factorizer, we are considering each word as a one feature. So we are going to consider each word, whatever the words are present, we are going to find what is the total number of unique words are present, and based on the number of unique words, we are going to consider these unique words become your features. Okay, so when we are working for the text data, in this case, definitely if you are going to use the count factorizer, if you are using the term frequency, inverse document frequency, then in this case you will get the huge number of data, because you are going to consider all unique values. Same like that, if you are working for the spam detection, you are going to consider at least 10,000 different email system, and if you are going to find the total number of unique words present in 10,000 different email system, definitely will find nearly equal to 50,000 and 1 lakh different unique words. And each unique words become your feature. Means overall you have the huge number of features, and if the number of features are 1 lakh or 50,000, 60,000, 70,000, then again it will take a huge time to process this data. So basically we are using the term called word embedding. This is word embedding. Basically what we are going to do. So here we can see what is the advantage of using the word embedding. So first we already know the count vectorizer. In the case of count vectorizer, what we are going to consider? We are considering each word as a one feature. We are considering each word as a one feature. So as for example, now assume that here the same like that we have taken high dimensional data. So now here we are taking high is one feature, dimension is one feature, and data is one feature. So we are getting three different feature. And if the any document containing only high, so we will write one. If any document containing dimension only, we are writing one in case of dimension feature. And if any document containing only the data, we are writing one to the data. So basically we are putting the data in the form of 0 and 1. So if this word is present in the document, we are putting 1. And if this word is not present in this document, we are putting 0. Okay. Now here you can see what is the disadvantage of using this model. So as for example, in this case, if you are using the count vectorizer, you can only find whether these two words are equal or not. Whether these two words are equal or not. Because in all the document, if the words are coming high and dimension and data, then we can say like that these three words are similar. These three words are similar. But if it is present in one document, if it is not present in second document, then in this case we can say these two data are not similar. But when you are using the word embedding, in this case basically this is similar like your dictionary. English to Hindi dictionary, something like that, or Hindi to English dictionary. So when what we are going to do, if we are going to find some meaning of English word, then in the dictionary we are finding the words, and after that, in front of that, we are getting the meaning of this English word. But when you are using the word embedding, basically the many company or many pre-trained models are there, or pre-trained dictionaries are there. They will give you the numerical value of any words. They will give you the numerical value. So as for example, height, they will give you the 10 different numerical value of this height. So if you are going to represent height, then in this case, basically you can use this 10 number. If you are going to represent dimension, you can use this 10 number. If you are going to represent data, you can use this 10 number. So basically they will give you the number representation of specific words. What is the advantage of using this word embedding? Based on that, you can easily find whether these two words are similar or not. So as for example, if you are going to find the word embedding of king, word embedding of queen, and word embedding of woman, then in this case, if you are going to find the similarity between king and queen, based on the word embedding, you will find more similar as compared to the previous one. So here you can easily apply the Euclidean distance. You can easily apply some similarity and dissimilarity formula. So nowadays we are using the word embedding, and based on that we can also reduce the number of features. So now assume that in the previous case we are taking the 50,000 different feature, because we are going to consider each unique word as a one feature. But in the word embedding, each feature means each word we are representing using the 300. Now assume that 300 different number. So what we are going to do, for each paragraph, we are finding the word embedding of each word, and then after that, we are going to aggregate all the words and we are making one single word embedding. So we are making one single word embedding for whole sentence. Means actually, if you are using the word embedding, then in this case, the number of feature is always fixed. You will get the 300 feature, but in the previous case, the number of features are not fixed. You will get the 50,000 different features. Now, second one, your high dimensional data, because when you are working for the count vectorizer term frequency, inverse document frequency, you will get the huge number of data. But can we say that all the data or all the features are important? So as for example, if you are working for the job recommendation system, same like that. Now assume that you are getting one objective, a student management system, and you are getting one objective like that. How many students whose CGPA is greater than 10 and 12th marks is greater than 90%, something like that. That in this case, there is no need to consider all the features, because when you are working for the student management system, there are various features are there: a student ID, a student name, a student age, a student CGPA, a student 10th marks, 12th marks, location, branch, all the details are present in a student management system. But based on this objective, we are going to find these are the two features are important to this objective: 12th marks and CGPA, because we have the idea about the same like that. Here we are getting the 50,000 unique word. How to decide whether this word is important or not? So here basically we are using the feature selection technique. Basically we are using the significance test, and based on that we are going to decide whether this feature is important or not, or whether this word is important or not, something like that. Now next one, your high imbalance data, because most of the data we are getting that is called the highly imbalanced. So same like that, in the email system, whatever the data you are getting, most of the data will come to the inbox. Very few data is going to the spam. So if you are getting the 1,000 mail, out of 1,000 mail, 800 mail will go to the inbox and 200 mail will go to the spam. So this data is called the highly imbalanced. Same like that, if you are talking about another scenario, you are working for the job recommendation system. You are going to consider the resume, and based on the resume, you are going to find whether the student will get job or not. Now assume that in your college, your average placement is 95%. 95% student will definitely get job, and 5% student will not get the job. Okay. Now you are using one model. You have developed one model, and model is always predicting whatever the resume you are going to put as an input. It is always predicting the student is getting job. Means always predicting a student is getting job. You will also get the accuracy of 95%, because the 95% placement record means 95% case you are getting the right answer. Only 5% case you are getting the wrong answer, because these 5% students are not going to place, but your model is saying like that it will fix. So here you can see we are getting the very huge accuracy, 95%, but still we are saying like that this is not a good model, because this model is always predicting a student will place. So first you have to also check if you are working for natural language processing. If you are working for any ML data, you have to check whether our data is suffering from class imbalance problem or not, whether the number of sample in both the class are same or not. You have to check whether the number of sample in both the class are same or not. If the number of samples are not same, then in this case you can use the different type of class imbalance problem. Okay. Now, before going for the NLP part, first we are going for the pre-processing. So first we are going to find the token. Token is the smallest unit in your NLP. So token is the smallest unit, means you can simply say like that the word. So simple word, single word, that is considered as a token. That is considered as a token. After that, we will also remove the stop words, because the stop words will not contain that much meaning. So you will remove the stop words, means like that D, each, comma, then column, then your points. So these all are called the stop words, and you can simply remove these stop words before going for the model development or before going for the feature extraction. So if you are working for the Python, then in this case you can use one library NLTK. You can use one library natural language toolkit, and based on that you can use the word tokenizer. Here you can put the sentence and it will convert to the words. So as for example, in this case you will get the token like bits, Hyderabad, campus. So you will get the 3 tokens present in this box. After that, you can also use the stop words. You can remove the stop words. What are the stop words present in your sentence? You can remove those stop words. So simply after removing this one, you get your book. Now, after that, the main objective is your feature extraction. How to find the numerical value from your text, because we cannot put the text as an input of any ML model. So our objective is to convert this text to the number. So most of the time we are using the VAC of word, or we are using the count factorizer. We are using the count factorizer. So this is a term for count factorizer. Here you can mention the n-gram. N-gram means basically we will mention the what types of word we will consider. Whether you are going to consider single word as a feature, or whether we are going to consider the 2 words as a feature, 3 words as a feature, also important. So as for example, when you are writing high dimensional data, try to understand what I am saying. High dimensional data, and if we are using the n-gram equal to 1, means we are using the single word as a feature. So we will write high dimensional data means whatever the feature we are going to take, high dimension and data. We are taking the 3 feature, high dimension and data. Okay. Now for high dimensional data, we will check whether the high is present in high dimensional data or not. Yes, present. So we will write 1. Now, second one, we'll check dimension is present in this data or not. Yes, dimension is also present. We will write 1. Now, second sentence you are getting data dimension height. Second sentence you are getting data dimension height, something like that. Okay, instead of high dimensional data, you are getting data dimension height. Again, if you are going to check high is present in this sentence or not, yes. Then data is present or not, yes. Then dimension is present or not, yes. So in both the case, we are getting the same value, 1, 1, 1 in both the case. But can we say both are same? One is called the high dimensional data, and second one is called the data dimension height. Can we say both are same? We cannot say both are same. But actually, based on the count factorizer, when we are going to consider n-gram equal to 1, we are saying both the data are same. So that's why we can also consider the combination of 2. So when we are going to write the n-gram equal to 1, 2, it will consider the feature like high dimension data, and then again it will consider the combination of 2 features, high dimension 1 feature, dimension data second feature. So it will consider high dimension is a 1 feature and dimension data second feature. So basically we are taking n-gram equal to 2 means we are also going to consider the combination of 2. When you are taking n-gram 3 means we are also going to consider the combination of 3. So here basically we will write how many combinations you are going to take. If you are taking the more number of n-gram, definitely will find the better model, but the complexity of the model will also improve. So normally most of the case we are taking n-gram equal to 1, 2, 3. Most of the test we are taking this one. After that, you can use the fit transform, and here you can put the text data, and here you will get the numerical value. So here x is nothing but your numerical value. So basically, it will convert this description text to one numerical value, that is called the x. So that is called the count factorizer, and that is also called the bag of word. Now, instead of taking in the count factorizer, we are only going to check whether this word is present or not. We are not going to check how many times this word is present in this text. So basically we are using the term frequency and inverse document frequency. So in this case, basically we are not only finding the whether this term or whether this word is present in this document, we are also finding how many times this word is present in this document, and based on that we are going to find the term frequency and inverse document frequency of a specific word, and this one becomes your feature, or this one becomes your numerical value of the sentence. So as for example, if you are working for the Python and if you are going to calculate the TF-ID value, then you can simply use these values and it will convert to the TF-ID. But the major difference is like that. In this case, it will contain only the value 0 and 1, but in this case, it will contain the frequency of the words. But nowadays, we are not using the word embedding, or we are not using the term frequency and inverse document frequency, because when we are going to consider those two terms, we will get the huge number of features. We are going to consider each unique word as a feature, which definitely will get the huge number of features. So nowadays, we are using the word embedding concept, and these are the various types of word embedding. Is pre-trained libraries are there. So these are the various types of pre-trained libraries are there, where you can put one single word and it will give you the vector. It will give you the numerical value of those words, and you can consider those numerical value as a feature. So in this case, if you are using the word embedding, you can get the fixed number of features, 300, 400, 500, something like that. You will not get the 50,000 features and 60,000 features. Now, after that, you can see, after that, we are taking the NLP data. Now, we are going to check which one is the best model. If we are going to consider the term frequency, inverse document frequency, or if we are going to consider the word embedding, which one is the best model. Because we already know, in this case, the number of features are very huge. If you are going to consider term frequency, inverse document frequency, the numbers of features are very huge. But in the case of the word embedding, the number of features are very small. So in the case of TF-IDF, we will get the number of features are 50,000, and when we are going to consider this one, in this case we will get the number of features equal to 500, 700, maximum we will get in the word model 750. So approximately 750 you will get in the word model, and the rest of the model you will get 200, 300. So if you are going to consider the number of features as compared to term frequency, inverse document frequency with respect to this one, then you will get the huge number of features. After that, we are basically, this one your NLP data, natural language processing. We are using the word embedding and term frequency. We are getting one data set that is called the numerical data. And after that, we are going to check whether this data is highly imbalanced or not. How to check? We have to check the number of samples, whether the number of samples in both the classes are same or not. If the number of samples are not same, then in this case, basically, we will go for the smooth technique. And after the smooth technique is basically, this is called the data balancing technique, basically used to balance the data. After balancing the data, now again we have to find whether all the feature, whatever the word we have considered, because we have the 50,000 words, we have to prove that whether all the words are important or significant predictor for this objective or not. So that's why we are using the significant feature. We are also using the cross correlation analysis, because this is also one important concept. So as for example, now assume that you are working for a student management system and you are getting one objective. You have to find how many students whose age is greater than 20 years, something like that. In this case, can we consider both feature, date of birth and age? There is no need to consider both feature, date of birth and age, because both are same. Based on the date of birth, you can find age, and based on the age, you can find the date of birth. So in this case, there is no need to consider both features, because both features are highly correlated. Both features are highly correlated, because in this case we have the idea about the domain, age and date of birth, both are same. But now assume that you are working for the 50,000 different words. It is not possible, manually it is not possible to find whether these two words are same or not. So in this case, basically we are using the correlation value. Based on the correlation value, we will find whether these two words are same or not. After that, we are using the principal component analysis, basically used to change the value of the, feature. So basically used to change the value of the feature means, as for example, now assume that if someone will give you the task to remember the value of x equal to 0.005, 0.006, 0.007, and second term, someone will give you the task to remember 5, 6, 7. Definitely the second one is more easy to remember as compared to the first one. But if you are going to check the data are almost same. What we have done, we have simply multiplied into 10 to the power 4 and we are getting the value 5, 6 and 7. So here basically we are changing the value. So some case when we are changing the value, we will get the better visualization or we will get the better pattern as compared to the original value. So here basically we are using the principal component analysis, and after that we are going to validate that which one is best technique, which word embedding is your best, which feature set is your best. So we are using the different type of ML techniques. So these are the different type of ML technique: Bernoulli naive-based classifier, multinomial naive-based classifier, logistic regression, Gaussian naive-based, support vector machine. So these are the various types of machine learning techniques. And after that, we are going to compute the performance, and based on the performance, we will decide which one is the best feature selection technique, which one is the best classification model, and which one is the best word embedding techniques. Okay. Now we already know what the feature selection is important. We already know we are getting the huge number of words. So there is no need to consider all the words. You have to prove that whether this word is important or not. So basically our objective is to remove the irrelevant feature and select the set of relevant feature. This is the objective of feature selection techniques. So here basically there are two categories of feature selection technique: feature ranking and feature subset selection. So in the feature ranking, based on the ranking of the feature, we are selecting the top words, and in the feature subset selection technique, we are going to find the best combination of the words. So for particular objective, what is the best combination of words? That is called the feature subset selection. So this is your overall work for the, if you are going to validate your feature, then first we will take the data, then normalize the data, then we will check whether this data is important or not, and after that we will also check whether these two words are same or not. If the two words are same, there is no need to consider both words, because when you are working for the machine learning technique, whatever the input you are going to consider, you make sure that all the inputs are uncorrelated. There is no any correlation between this input. And if the two inputs are highly correlated, there is no need to consider both input. We will consider exactly one input. Now, this is a formula basically used to check whether this word is important or not. And based on the box plot diagram, you can easily find whether this word is important or not. So I'm not going through that. So in the Python code, you can simply use this rank sum test to find whether these two words are important or not. And based on that, you will check how many words are important and how many words are not important. Now, after that, this basically we are finding what is the accuracy of the model, because in this case our data is highly imbalanced. So most of the time we use the area under curve. Based on the area under curve, we will make the conclusion. So here you can see in the smooth data we are getting this area under curve, and if you are getting the area under curve greater than 0.7, then you can consider this one as a best model. If AUC value greater than 0.7, you will consider as a best model. So here you can see we are using the term frequency, inverse augment frequency, and these are the different types of word embedding, and this is the accuracy value. And now you can see if you are going to check it, in this case most of the time we are getting in this case, but if you are going to compare some case in the word embedding, we are getting the better result. So as for example, here we can see we are getting 0.98, 0.98, 0.97, something like that. So that is we are getting the best model in the case of word embedding with respect to TF-IDF. If you are going to compare with the box plot diagram, that here you can see, if you are going to use this term called globe and word to vector, then in this case you will find the better accuracy as compared to term frequency and inverse augment frequency. So here you can see the advantage of using the word embedding. Based on the word embedding, you are getting the low number of features. You are getting only 300 features. But if you are using the TF-IDF, you are getting the 50,000 features. If you are going to compare the performance, we are also getting the better performance in case of word embedding. But in case of TF-IDF, we are getting the lower performance as compared to globe and word to vector. Same like that, if you are going to consider all feature, significant feature, cross correlation and PCA, now you can see in the case of cross correlation, we are getting the better performance, because the red line top means better performance. So we are getting better performance as compared to this one, because all feature means we are going to consider all words, but in the cross correlation analysis means we are not going to consider the similar words. If there are two similar words are present, we will remove the similar words. Same like that, if you are going for the different classification technique, that now you can see. So here basically in the case of SVM with polynomial and RBF kernel, we are getting the better performance as compared to the name-based classifier, logistic regression, decision tree, and neural network. And after that, you can make the conclusion. So basically what we are going to do, first we are taking the word embedding or we are taking the count factorizer. Then after that, we are applying the feature selection. We are not directly going for the machine learning technique. First, we are finding whether these words are important or not. If these words are important, then we are also going to check whether these two words are highly correlated or not. If the two words are highly correlated, there is no need to consider both words. We will consider single word. Then we are going for the different classification technique. Based on the different classification technique, we will make the conclusion which one is the best word embedding technique, whether the term frequency is best or the word embedding is best. And based on the different types of classification, based on the different data set, we will make the conclusion which one is best. So as for example, in this case, we are making the conclusion like that: globe and word to vector is best for the NLP, not the term frequency and count factorizer. Same like that, if you are using the different classification technique, then support vector machine will give you the better result as compared to the other techniques. So same like that, these are the conclusion for this work, and there are some selected references. So if you are interested, you can go through this paper. If you have any question, then you will ask.